Hi everyone, I hope you're okay. And I really hope that guys the videos will keep uploading and helping you out. This is the 33rd video, and I'm doing the last question as promised. It's been a long journey, guys. I'm thankful for those who watched from the first video until this one, with regards to organic chemistry. Uh Inkosi Benani. Inkosi Benani, and I wish you a very fruitful academic year. Okay, let's start, guys. The flow diagram shows the different organic reactions. P, Q, and R are organic compounds. Okay, and then yeah, we do have our flow diagram then. Before we just answer the questions, let's just observe our flow diagram. We had compound Q, and something happened to compound Q, and we ended up having um, a dibromo methylpropane together, which simply means that compound Q was an unsaturated hydrocarbon together. So compound Q was this hydrocarbon, but the difference is that it was just unsaturated together. So the structure of compound Q, the parent chain had 3 carbons, and then at carbon number 2 you would have your side chain over there, and then between carbon number 1 and 2 we had a double bond. We had a double bond between carbon 1 and 2. Our structure just looked like this. Together, such that whenever we add this bromine water over there to form this compound there, the double bond will have to separate, and then we will now have our dibromo 1.2 dibromo. So initially our compound Q was just an unsaturated hydrocarbon, and its IUPAC name is just 2-methyl-prop-1-ene. It's 2-methyl-prop-1-ene. That's the IUPAC name altogether, 2-methyl-prop-1-ene. Okay, and then now let's go to reaction 2. Reaction 2, we are taking our methyl-prop-1-ene, we are reacting it with hydrochloric acid. It's hydrogen chloride gas, rather, excuse. It's hydrogen chloride gas, and then we will form a major product. The structure of compound Q. Remember that we had methyl-prop-1-ene like this. And then we are adding HCl. We are forming a major product, right? Whenever, guys, we are dealing with addition reaction, and whatever that we're adding has a hydrogen atom, please note that we'll always follow Markovnikov rule together. The hydrogen atom will be bonded to the carbon with the highest number of hydrogen. So the hydrogen atom will come over here, and then the chlorine will come over there. Together. That's how we will form our major products. And its structural formula will look like this. Let me try to do this. Okay, 1 2 3 1 2 3 with the CH3, 1 2 3 again. I do have my hydrogens over there, but now the added part will be like this, H and Cl over there, such that the IUPAC name of compound R would be 2-chloromethylpropane. Okay, and then now for reaction 3. We are dealing with substitution reaction. Now together we are moving from a haloalkane to an alcohol. This type of a substitution reaction is called hydrolysis. Together, what will happen is that for compound P, the chlorine will be substituted with an OH together. So the structural formula for compound P will be like this. I do have my hydrogens over there. The only difference is that I'll simply have an OH there. Are we together? So the type of reaction is called substitution reaction, yeah? And then the type of substitution reaction is just hydrolysis. For reaction 2, remember that for reaction 2, this was reaction 2, right? We add in a hydrogen halide. So this was addition reaction, and the type of addition reaction is hydrohalogenation, since you are adding a hydrogen halide. And then for reaction 1, it was also addition, and the type of addition reaction, it was halogenation, and the type of halogenation reaction, it's called the bromination. Okay, and then now let's go to reaction 4. Reaction 4, we are moving from an alcohol into an unsaturated hydrocarbon. So what will basically happen is that we will simply eliminate these two. That's H2O. Are you together? So that's an elimination reaction, and the type of elimination reaction is dehydration, since we're eliminating H2O. Okay, now let's answer the questions. For reaction 1, we are told that reaction 1 is an addition reaction. Okay, and we did say that reaction 1 is addition, right? 4.1.1, write down the type of addition reaction. This is halogenation. Reaction 1 is halogenation, or you can simply say it's bromination. Okay, write down one observable change which occurs in the container during the reaction. There will be a change in color. There will be a color change. The reaction container will turn into brown. Will change into a brown color. Okay, 4.1.3, the structural formula of compound Q. We did write the structural formula of compound Q, right? It's methyl prop 1-ene. So the structure will just be like this. And my hydrogens over there. Do not forget the double bond there. Okay, and then now let's go to reaction 2. Reaction 2, they just want us to write the IUPAC name of compound R. This is our compound R, right? Remember that reaction 2, we are moving from an alkene and we are adding HCl together, and we will form a major product. Whenever we form a major product, we will forever follow Markovnikov rule. Are we together? So this will be the structure of our major products, and the IUPAC name of our major products will simply be 2-chloro 2-methyl propane. Okay, and then now let's go to reaction 3. Using a balanced equation, write down the balanced equation using structural formula for the organic compounds. Okay, they want us to write down the balanced equation for reaction 3. Remember that reaction 3, guys, is hydrolysis, right? You are moving from a haloalkane to form an alcohol. So that reaction will simply look like this. We are moving from a haloalkane, which is a side chain like this. Hydrogen, 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 hydrogen. And then remember that we had our chlorine over there, né? For us to form an alcohol, guys, we will need to add we will need to have a dilute strong base. Our base can be potassium hydroxide, sodium hydroxide, or lithium hydroxide, né? I'm just choosing to go with sodium hydroxide. Are you together? And another condition that is needed for this substitution reaction is mild heat. Okay, so what will happen over here is that I will form an alcohol. I'll form an alcohol. I'll still have my hydrogens over there. Hydrogen, hydrogen, hydrogen. And then the Cl will switch places with the OH. I'll simply have an OH over there. Since the Cl and the OH have switched places, the inorganic product which will be formed, I'll just have a sodium chloride out together. And then the IUPAC name of my my alcohol which is formed, I simply have 2-methyl propane to all. And this type of an alcohol is a tertiary alcohol, né? Okay, we have written the complete reaction. Are you together? That will be our complete reaction. Others would prefer to write it like this. Others would prefer to write it like this: plus NaOH, which is dilute, and then they'll just write heat or mild heat over there as the reaction condition. Others would prefer to write the complete reaction like this, né? And there's nothing wrong if you do this, guys. So the IUPAC name of our organic product P is 2-methyl propane to all. 2-methyl propane to all, né? That's 2-methyl propane to all. Okay, and then for reaction 4. Reaction 4 is an elimination reaction. We did state that reaction 4 is an elimination reaction, né? And we did specify that this type of elimination reaction, it's dehydration. Okay, they want us to write the type of elimination reaction. It's dehydration. Okay, and then we are told that butane 1-ol reacts with propanoic acid in the presence of a catalyst. Whenever, guys, we mix a primary alcohol and the carboxylic acid, you will forever form an ester. Are you together? And the type of a catalyst that you will need is just a concentrated sulfuric acid. Okay, and then now they want us to write the type of reaction that takes place. This is esterification, since you're forming an ester. And then the IUPAC name of the organic product. The alcohol part, guys, is referred as the alkyl part. Are you together? So since the alcohol had 4 carbons, that means the IUPAC name for the ester will be butyl, and then the acid had 3 carbons since we used propanoic acid, so it will be butyl propanoate. Yeah, that's how, guys, we're supposed to tackle this question. I really hope that, guys, the video helped you out. Just stay tuned, guys, and wait for more videos. I'll be definitely uploading other topics. I think after organic chemistry, I'll be uploading work, energy, and power, followed by Doppler effects, maybe electrostatics, and then I'll start with rates of reactions and stuff. But guys, just stay tuned, and I thank you guys for giving yourself time to listen to my videos, and I hope they're helpful to you. I really hope they are. For now, don't forget to subscribe, share the link to your peers, guys. A thing or two that is always mentioned on my platform. I believe that it will help them. So please do share the videos to your peers. You might be helping them, and please tell them to subscribe too. Bye.